welcome back. Now that everybody's had fun playing with the latex tubing, I want to point out a couple things here. Now, depending on how hard you flicked it, I saw some people playing with it and getting four crests. Now, when I say four crests, when you look at it, it goes up and down like that. Now, if you think about it for a minute, that's a crest and a trough. Actually, that's one crest and one trough, or one wavelength. Now, you guys have shown me if I give you frequency and velocity and whatever, you can figure out wavelength and velocity, whatever. I'm not going to give you more of those questions to practice on in class. I'll just give you a few for homework practice. But note here, this whole thing is two wavelengths. All right? Now, one of my favorite trick questions is, where do you start measuring? Well, it doesn't matter as long as you get repeats. Now, here, yes, antinodes. I wasn't going to do that today. And the node is where they go up and down. So here, as long as you've got one complete wave, you've got a one wavelength. Now some people say, some people will say that's a pain to measure from center to center because you got to get there. It's a lot easier to measure from peak to peak. Some people will measure peak to peak. Some people will measure trough to trough. Doesn't really matter as long as you get one whole wave repeating itself. All right? What else was I going to say? Node, wavelength. So you've got two complete waves here, up and down. The trouble is you're flicking it so fast, it looks like a crest and a crest and a crest and a crest at the same time. But it's a crest and a trough and a crest and a trough. It's just going so fast you can't see it. It's blurring together. Yes?
If you measure from the crest, you've only got one.
Okay, well, you measure, this is going down and coming back up. So when I say a crest, go down like this and back up again. So this is one crest to another crest.
Yeah, but so if you counted that one, the crest, it's only one wavelength. If you count from the antinodes, it's two. So
well, you go from here to here, you've got one complete wave going up and down. Oh, I see what you mean. Sorry. So the problem is here, guys. Eli, I didn't explain as well as I could. I'll try this again. There's your one wave, or your two waves in the elastic band. Trouble is, a fraction of a second later, this flips back and goes like this. So, when I say measure crest to crest, or trough to trough, it's one wave going down. So you'd measure crest to crest here. All right? The problem is, unless you've got really good eyes, you see another crest in here and that can confuse things. All right? So be careful about that.
Because isn't it the same length?
Yes. So honestly, all you really have to do, if you've got a mess like this, just measure from here to here and double it. That'll be half a wavelength. Okay? Now, sorry, I should stop there. See, the trouble is playing the rubber band, it does look like you've got two crests. Yeah, sorry. If we can make it really long, maybe we'd only get one wave in there. But crest, trough, that's two complete waves. Most people, measuring from the middle is kind of hard, but peak to peak is easier. So, actually, I have an example question on that. Let me show you. Okay. All right. You're floating on Lake Lake W. Shush. You go Lake Winnebago. You note you go up and down 8 times in 3 minutes. It's one of those, the 2 days of the year it's not windy. Okay. So, slowly going up. Well, Lake Waganami is like, what, 9 meters deep, 9 feet deep in the middle?
Well, no, we're talking about Winnebago, aren't we?
Okay, just for you, Kyle. Since the lake is only about 3 meters deep in the middle, let's say the waves are about 1 meter high. Really, what'd you say, 10 meters? 15? Oh, God, no. All right, so there you are. It's a little bit windy in Lake Waganami. And there you are on your raft, sunbathing, going, I don't have to deal with Mr. Sutton anymore because I passed Physics 20. Woohoo! Okay. One, I don't want to know how you know that, because 2, your phone is put away, isn't it? Okay. All right. While I'm playing a musical song on somebody's forehead, I want the rest of you to figure out the velocity of the wave. Oh, God, stop that. Stop that. All right, so what's the formula? Yes? Good question. People keep borrowing it. Sometimes they dump it on the back table there because it's too lazy to take it over here. Now, yes. Now, shush. We will deal with that later. I'm just going, please, bring in some musical instruments, or that's what we're going to have to play. Okay, what's the formula for velocity? Frequency times wavelength. Did I give you a frequency? Careful. Up and down 8 times in 3 minutes.
Would it be 8 over?
Yes, but if I'm going frequency is what?
1 over time.
1 over time, or, careful, it's hertz, it's cycles per second. So how many cycles do we have? How many waves do we have? 8 waves. 180 seconds. So frequency is what? All right. 3 minutes. Now, I didn't tell you the wavelength, but crest to trough, say, is 7 meters. So, if crest to trough is 7 meters, what's the wavelength? Yes. This is 1/2 wavelength. Well, the height of the waves. Yes, I threw in an extra number just to screw with your mind. Did it work? No. Bonus. All right. So, 0.04 hertz times 14 meters. What's the velocity of my wave?
0.62. Well, 0.6.
Okay. So
And the question gave us wavelength?
no, I put in 7 meters. No, I gave you 7 meters on the diagram. I didn't tell you 7 meters. I put 1 meter high just to confuse you. All right. Now, so far so good? All right, so double check. Is it 0.62 meters per second? wavelength. All right. So 0.62 meters a second. So there we go. That is the velocity. Now, we have one. You guys feel like going and annoying the hell out of everybody in the school? All right. So we're going to go do a lab on this. All right. Turn this off because I don't want